Alright, so welcome to a video for Math 2 Section 2-3, which is going to be on proving parallel lines. So there is a printout if you don't want to write everything I'm going to show you. And you're also going to want to have your book handy because I'm going to go over some examples in your book. Okay, so before we get started here, let's just do a little review. So we learned about a transversal and two lines, and we learned about corresponding angles like those two. 1 and 2 would be corresponding. We learned about alternate interior. Angle 2 and angle 3 would be alternate interior because they're on the inside and they alternate sides of the transversal. And we learned about alternate exterior. Let's say angle 1 and angle 4 would be alternate exterior. And I'll put an angle 5 here. Angle 2 and 5 would be same side interior. And what we saw is that, let's make this a little smaller. Angle 1 would be congruent to angle 2, right? Corresponding angles are congruent. But then because of vertical angles, angle 1 would be congruent to angle 3. So that made alternate interior angles congruent. And also because of vertical angles, 2 and 4 would be congruent. So angle 1 and angle 4 would be congruent. Those are alternate exterior. Then we saw that angle 2 and angle 5 would not be congruent, they would be supplementary. Same side interior angles are supplementary. Now, all of this is true only if these two lines are parallel. If they're not parallel, we could still call them the angles that they are, corresponding, alternate interior, alternate exterior. We just can't say that they're congruent or supplementary. And back to the angle 5 here. Angle 5 would be congruent to this angle and these two angles. So you have this sort of checkerboard pattern happening. Okay, so that's what we learned. So now we're going to basically just reverse it. We're going to do the converse of all of those theorems. So you may remember from Math 1, a converse of a conditional statement. Well, a conditional statement is if something, then something. So if A, then B. Right? This is called the hypothesis and this is the conclusion. So a converse of a conditional statement is when you flip the hypothesis and the conclusion. So we would get if B, then A. It is not automatically true that both, if this is true, then this is true. So that's why we're actually going to name these with new theorems. Okay? Alright, so let's look at the first one here. This is Theorem 9 from your book, and it's the converse of the corresponding angles theorem. So it's the reverse of that one. And what do we have in it? Well, it says if two lines in a transversal form corresponding angles that are congruent, then the lines are parallel. If you look back at the one that we had from section 2.2, this is reversed. That one said if a transversal intersects parallel lines, then the corresponding angles are congruent. So this is all backwards. So for this diagram here, if angle 2 is congruent to angle 6, those are corresponding angles, then we can say those two lines are parallel. Alright, now the corresponding of the alternate interior, or sorry, the converse of the alternate interior angles theorem pretty much says the same thing, except we're replacing the words corresponding with alternate interior. So here we have, if two lines in a transversal form alternate interior angles that are congruent, such as 4 and 6 in this picture, then the two lines are parallel. L and M are parallel. Okay, moving on. Actually, I'm going to come back to that one. This is the bottom one. This one is the converse of the alternate exterior angles theorem. So we have pretty much the same idea. If we have alternate exterior angles that are congruent, then we have parallel lines. So if angle 1 and angle 7 are congruent, then L and M are parallel. Now this one that I skipped, this one is for the sort of odd man out, right? This is for the same side interior angles postulate. And the same side interior angles postulate said that if you have two parallel lines, then you have supplementary angles, supplementary same side interior angles. This is backwards from that. This is saying if two lines in a transversal form same side interior angles that are supplementary, so add up to 180, then the two lines are parallel. So if angle 3, say, is 100 degrees, and angle 6 here is 80, then you can see that 100 plus 80 equals 180. So they would be supplementary. That would make the lines L and M parallel. Okay. This page, you can see this is going to go on page 15 of your notebook. And these are going to go on page 14. These are some examples. Okay. So it says, decide if there's enough information to say that there are parallel lines, then state which lines and that are parallel and why. Okay, right now all the examples look the same and there's nothing really on them because I'm going to add to them. Okay, our first case here is, let's say this angle right here is congruent to this angle right here. So you want to focus on just the 3 lines that you need to focus on. I know there are 4 lines there. Just focus on the ones you need to focus on. So what I mean by that is the relevant lines. So line E, and line M make up that one angle on the left, and M and F make up this angle over here. N has nothing to do with this, so just ignore it. So now you should be able to see what kind of angles they are. They're alternate exterior, which means that these alternate exterior angles need to be congruent for the lines to be parallel, which they are. So the parallel lines here are going to be E and F. So we'd see E is parallel to F by the alternate exterior angles. Oops, I forgot a very important word here. The converse of the, right? Because the converse is the one we're talking about. So it's by the converse of the alternate exterior angles theorem. If I didn't put the word converse, that would be wrong because I'm using the other one, which is backwards. Okay, let's do another one. Okay, let's say in this case, I tell you that this angle right here is 92 degrees, and this angle right here is 108 degrees. Well, we have to think, what kind of angles are they? They're same side interior. So if they're supplementary, we should check to see if they're supplementary. We're checking to see, do they equal 180? No, they equal 200. So it's too much. It's not equal to 180. So we cannot say that there are any parallel lines. So no parallel lines. Even though everything looks parallel, we have to go by what the information tells us. Okay, let's go on the next one here. Let's say we have this angle and this angle are congruent. So first think, what kind of angles are those? Those are vertical angles. Okay, and vertical angles are always congruent. And they don't even have to do with a transversal, right? There's this line and this line. That's it. We don't need any of the other lines. These don't affect these two lines at all. So we don't have a pair of parallel lines. So this is another case of nope, none. Okay? All right, now these are pages from your textbook. So you don't need to print these out. You're going to go to page, let's see, this is page 83 in your textbook. And I'm just going to go through a couple examples with you. Okay, I want to look at this one. So if you need to, pause the video, go find your textbook, go to page 83. All right, we're ready? So this says, which lines or segments are parallel? Justify your answer. This looks a little different. These are some triangles. But we do have a transversal here. Let me get a good color. This thing at the bottom, that's like a transversal. And then we have two possible lines. Now, just because they're not making complete lines with arrows doesn't mean you can't draw lines over them. Okay, when we look at it like that, we see we have a 45-degree angle here, 45-degree angle here. Those are corresponding angles. So we do have parallel lines by the converse of the corresponding angles theorem. So which lines? These two. Line CA is parallel to line HR. Here and here. So I just want you to see that what it looks like in triangle form, because that's actually going to come into next chapter. We're going to look at triangles, and these theorems are going to come up in that chapter. Okay, going on to the next page, page 84, we're going to talk about something called a flow proof. This is a flow proof. All right, we've looked at two-column proofs. This is a different kind of proof from that, called a flow proof. So there's a good description here. The proof of the converse of the alternate interior angles theorem below looks different from any other proof you've seen in this course. So this third form is called the flow proof, and it's called a flow proof because the arrows show the logical connections. It's showing the flow. Think of it like a version of a flow chart or a flow diagram. So it's showing logical connections between the statements. Okay, so given, let's take a look at it. Given angle 4 is congruent to angle 6. Okay, so that's given. You can see we have the statement in a box here, and then the reason is written underneath. All right, now there's another statement here. We have angle 2 is congruent to angle 4, and the reason for that is vertical angles are congruent. Now if we use the transitive property, we can put these together. That's why there's two arrows coming together into one box here. If 4 is congruent to 6 and 2 is congruent to 4, they're both congruent to 4, so they're congruent to each other. That's the transitive property. And then going from that, we can say, well, since 2 is congruent to 6, L and M have to be parallel, and that's by the converse of the corresponding angles theorem. But if you don't want to name it, you can just describe what it says like they did. They say if corresponding angles are congruent, then the lines are parallel. Or you could just say converse of the corresponding angles theorem. All right, next page, we're looking at page 85. So we're going to practice doing a flow proof. So you can see these question marks. We're filling in the missing parts of the flow proof. A, B, C, D, and E. So I want you to pause the video right now and I want you to try and figure out what those are on your own. Okay, did you figure them out? Alright, let's see if you got the right answers. So we have that angle 1 and angle 3 are supplementary. Angle 1 and angle 3 here are supplementary. Okay, that is given. So A is given. Alright, B says definition of a linear pair. Definition of a linear pair basically means you can look at a picture and you can find a linear pair. And there's only one linear pair here, and that's angle 1 and angle 2. So the statement here is angle 1 and angle 2 are a linear pair. So that goes there, B. C is the reason for why angle 1 and angle 2 are supplementary. The reason for this is that a linear pair is supplementary. So you can actually write out linear pair angles are supplementary. I don't think this book calls it this, but in other books that's called the linear pair postulate. So I would accept that too. Alright, D, we're looking at the statement. Supplements of the same angle are congruent. Okay, so that's the congruent supplements theorem that we talked about in class. But you could write congruent supplements theorem, or you can write what they wrote here. But the statement is, well, we have angle 1 and angle 3 are supplementary, and angle 1 and angle 2 are supplementary. So since 3 and 2 are both supplementary to 1, they're congruent to each other. So the answer there is angle 2 is congruent to angle 3. Now look at what angle 2 and angle 3 are. Those are corresponding angles. We have just proven that they are congruent to each other. Our goal, what we're trying to prove, is that you have parallel lines A and B. So if two corresponding angles are congruent, then that means that these two lines are supplementary. So that is, you can write out the whole theorem name, which is the converse of the corresponding angles theorem. Or you saw in the example up here that they wrote this out. They pretty much wrote an abbreviated form of the theorem instead of writing the theorem name. Either one's accepted. Okay, one more problem and then we'll be done with these notes. This is page 86. We're looking at the one that says problem 4. So the question is, what is the value of W for which C is parallel to D? This isn't that different from the problems in 2.2. They're just asking the question in a different way. They're asking what value of W, when you plug it in, would make these two lines parallel to each other. Well, we know these are corresponding, and corresponding angles should be congruent. So we're going to take 55 and set it equal to 3W minus 2. I'm going to add 2 to both sides. 57 is equal to 3W. Divide by 3. Now that looks ugly, but 3 actually does go into 57. 1, 3, 27, it's 19. So W would have to be 19. Okay, and we are done.